So the last thing we covered, if I recall, was multiplying and dividing fractions. Is that the case? I'm just making sure I'm remembering right.
I believe so, yeah.
Okay. Yeah, the reason I get confused is because, yeah, this material overlaps with almost all my classes. Okay, so we are going to do 1.3, which is adding and subtracting fractions. And then we're done chapter 1 at that point. So let's actually decide on the due date for the assignment because it's posted already. Let's say that it's due next Wednesday, and then we'll take it up on Thursday. And I'll also post that online just so it's in writing. So due on the 22nd, taken up on the 23rd. So if you're going to hand it in late, you only have just that one day in this case. Okay, and for the test, I think I'm going to wait and cover chapter 2 before we have our first test, and it'll be on chapter 1 and 2, so fractions and decimals and percent. I think that's the best way to do it because fractions, there's just not that much material. So yeah, we'll wait on that. Okay, let's start. So 1.3, let me just check. So we're still recording, good. Okay, so 1.3, adding and subtracting fractions. So like I mentioned in last class, multiplying and dividing fractions is surprisingly easy. Yeah, but adding and subtracting fractions is a little more challenging, and there's actually kind of like a series of steps that you do have to go through in order to add fractions. So we're going to start off with the simplest possible example, which is where you're adding fractions where they have the same bottom number. So they have a common denominator, as they say. So in this case, it is very straightforward. So here's the example. We have 1 over 10 plus 2 over 10, and surprise, surprise, we get 3 over 10. So with our pizza analogy, it's like cutting a pizza into 10 slices. You take one of them, you add 2 of them, and you get 3 slices. You get 3/10 of a pizza. So like I said, this is easiest possible case. And if you want to get really technical with the rule for this one, the rule would be add the top numbers and the bottom number just stays the same. You don't add the bottom number because the size of the slices doesn't change. You're just dealing with tenths in this case. So that would be the rule for that. Let's do one more where we have a common denominator. So 2 over 8 plus 3 over 8 plus 4 over 8 is equal to 9 over 8. So again, bottom number stays the same, even in the answer, and then you just add up the top numbers. But if the bottom numbers aren't the same, it's a little more work. So let's look at an example of that, and we'll go through it step by step. Let me stop sharing. And let's go to a whiteboard. Okay. Whiteboard. So the simplest example I could think of is 1 over 2 plus 1 over 3. So in this case, you don't have the same bottom number. So basically what you have to do is you have to take each of these fractions and rewrite them with the goal of getting the same number on the bottom for both of them, but you don't want to actually change the value of each fraction. You want them to be equivalent to what they were. So the first step is you find what is called your least common denominator. And the way you find that is you look at 2, you look at 3, and you ask yourself, what is the lowest number that is a multiple of both those numbers? And a lot of the times you can just deduce it just based on observation, but there are various methods for finding it. In this case, if you really couldn't figure out what's the lowest multiple of both these numbers, worst comes to worst, you could just list the multiples of the numbers. So like 2, 4, 6, 8, etc. And then for 3, you got 3, 6, 9, 12, etc. And you just look at the lowest number that happens to be on both of those lists. So 6 will be our least common denominator. So that's what eventually will be the bottom number for both of these. So let's write that down. LCD equals 6. Okay, so next step is take each of these fractions and rewrite them. So let's start with 1/2. So what we want to do is take 2 and multiply it by a number that will get us to 6 on the bottom. So 2 times what number equals 6, and you just use whatever works. Of course, in this case, 3 works. So you multiply the bottom number by 3. But as we previously mentioned, if you do something to the bottom of a fraction, you have to do the same thing to the top. So you also multiply the top by 3. So this way you'll get a 6 on the bottom, but it's still going to be the same fraction as what it was. In this case, it is 3/6 for this particular one. So good. Now it has a 6 on the bottom, and of course 3/6, it's the same as 1/2. And then you do the next fraction, and you go through a similar process. Next fraction is 1/3. So you ask yourself, 3 times what number will get you to 6? And in this case, it is 2. So you multiply it by 2. And then, of course, multiply the top by 2. So where I'm getting those numbers from, like where I'm getting 2 from, is just trying to get 6 on the bottom using multiplication. So this is 2/6. And then finally, you have equivalent fractions that have a common denominator. So you just add them up. 3/6 plus 2/6 is equal to 5/6. And that's the general process for adding numbers or adding fractions that don't have common bottom numbers. So you always have to find your least common denominator, which is a multiple of both bottom numbers, and you pick the lowest one. That way you won't have to reduce your answer. And then you rewrite each of them and then add them up. And yeah. What else can I say about this particular example? Oh, and we could kind of do a bit of a visual analogy of why this works. Let's do that. Let's look at 1/2 in our pizza analogy. Actually, let's just draw a pizza. Here's a pizza. Pretty good, solid drawing. And 1/2 is, darn it, let's say, wow, this is so, okay. It's horribly drawn, apologies. So let's say pretend that that's divided up into actual 2 equal halves. So 1/2 would be, let's say, this one right here on this side. But by writing it as 3/6, basically you're just kind of dividing it up into further slices, like, let's see, like this and like that. So it's actually the same size. You're just kind of looking at it in a different way. So 1/2, it's the same thing as 3/6. And then the 1/3, let's see if I could properly draw 1/3. 1/3 is, let's say, right here. And yeah, so taking 1/3 and writing it as 2/6 is basically just kind of dividing it like this. And you got these 2 pieces right there. And as you can see, you got 1, 2, 3, 4, 5/6 of a pizza. So that's the visual analogy, the horribly drawn visual analogy as to why this works. What else? So let's do some other examples. And on this slide, it just kind of lists the guidelines for this. It says find the least common denominator, rewrite your fractions so that they have this common denominator, and then add them up. Let's look at another one. So 3/4 plus 1/5. So first step, figure out what is the lowest multiple of 4, and that's also a multiple of 5. So again, in this case, if you were really desperate and you couldn't figure it out, you could just list multiples of 4. So 4, 8, 12, 16, 20, etc. And you could list multiples of 5, 10, 15, 20, etc. And as you can see, 20 is the lowest number that happens to be on both of these lists. I wouldn't recommend doing it this way just because, again, usually you can do it kind of by observation. This is just like a brute force method, which usually isn't, aren't very elegant methods in math. My favorite method is what I do is I just look at the largest of the bottom numbers and I start cycling through multiples of that. and then I just choose the first one that works for 4 as well. So I just look at 5, 5 doesn't work, 10 doesn't work, it's not a multiple of 4, 15 still doesn't work, not a multiple of 4, 20, bam. So that's what I do. I just find it a little bit easier to focus on one of the numbers and then just kind of compare it to the other one. That's my favorite method of doing it. What other methods are there? There's one called prime factorization, but we'll save that for later. Okay, so least common denominator is 20. So now let's take each of these and rewrite them so that we have 20 on the bottom. So in this case, what should I multiply this fraction by? What should I multiply on the top and the bottom?
5 to make 20.
Exactly. So multiply by 5, multiply by 5, and it always has to be the exact same number that you're multiplying on the top and the bottom. Just like when we were reducing fractions to lowest terms, it always had to be the same on the top and the bottom. This is basically just bringing a fraction up to higher terms. It's kind of just the opposite of reducing to lowest terms. So it's 15 over 20. Next one is 1 over 5. So what should we multiply this one by? Anyone?
Multiply that one by 4.
Indeed. So multiply by 4, multiply by 4, and you get 4 over 20. So, and now add them up. So 15 over 20 plus 4 over 20 equals 19 over 20. And most of the time, the answer will be in lowest terms. Sometimes it won't, so keep an eye out for that. But for some reason, mostly it ends up in lowest terms already. Good. Okay, maybe we'll do, oh, this next one is a little bit different. So let's do that. And in terms of this being on an assignment or a test, typically this will be out of 4 marks. There's 1 mark just for the fact that you know what the least common denominator is. And then let me think of how it's exactly broken down. And then I think it's 1 mark each for changing each of these fractions, and then 1 mark for adding them up and getting your final answer. I think that's roughly what I usually do. But typically they're out of 4. Okay, let's do another one. So this one is 2 over 5 plus 3 over 10. So let's use my method for finding the least common denominator. Let's just look at the largest number on the bottom, which is 10. And in this case, you don't have to do much work because 10 itself works, because 5 is a multiple of 10. And trivially, 10 is obviously a multiple of itself. So it works. So in this case, you could just use 10. Least common denominator equals 10. So sometimes it will be one of the bottom numbers. It'll at least be as big as the largest one or larger. Okay, so let's rewrite each of these. For the 3 over 10, you don't have to worry about it. It already has a 10 on the bottom, so that stays the same. So you only have to write the 2 over 5. Oh, and someone is chatting. Someone said, is there a proper layout I'd like everyone to use for writing the assignments or the test? I'm not totally sure what you mean by layout, but just as long as I can roughly follow your work, then that's fine. Yeah, anything, yeah, nothing more specific than that. But if you mean something different, then let me know. So for this one, let's do, so we've got to get 10 on the bottom. So let's multiply this by 2, multiply this by 2, and then you get 4 over 10 for that one. So now let's add them up. So we got our 4 over 10, and then we got our 3 over 10 right here. And that's 7 over 10. And that does not reduce because 7 is a prime number. So you can kind of automatically see that it doesn't reduce. What else? So there is a very common mistake that some people make with adding fractions. And let's do the same example, but we'll show the incorrect way. Sometimes a person will just add the top numbers and then just add the bottom numbers, and they'll cite that as the answer. You don't do that. No, it doesn't work. I could kind of understand people's logic. I think that what's happening is that people are confusing adding with multiplying fractions, because multiplying fractions is really easy, and it's like you just do the top, you do the bottom. I think people commonly confuse it with that. So you just have to remember that adding fractions is the one that's a little more complicated. You can't just directly add them. Yeah, because it wouldn't make sense regardless. I'm sure you could easily come up with counter examples that show that this method just doesn't make any sense. Let me think of a counter example. Hold on. I'm just trying to think of a good one. Because I have one in the lesson, but it's not one, or not in the lesson. I have one I usually use, but I don't really like it anymore because some people got confused about it. I can't think of one right now, but yeah, this method of directly adding them, it doesn't work. Let's see, what else is there? So let's do some prime factorization. So this is a more algorithmic formulaic method of getting your least common denominator. It's a little more complicated than the other little methods that we've done, but it'll always get you the right answer, and it'll always get you the least common denominator. So let's take a look at that. So let's say you have 1/6, you got 1/4, and you got 2/15. And let's say you want to figure out what is the least common denominator for this. So what's the lowest number that's a multiple of 15 and 4 and 6? Even for this example, I still think my method is the best, to just look at 15 and just cycle through multiples of 15 and just see which one works. But let's use our new fancy prime factorization method. So this is how it works. You take each of the bottom numbers and you break them down into their factors, into their prime factors. So for example, 6 is 2 times 3, 4 is 2 times 2, 15 is 3 times 5. So now these are all broken down into their prime factors. And now what you do is you come up with the smallest string of numbers that has all of these factors present in it. So let's do these kind of one at a time. So we need let's look at the middle one. We need a 2 times 2. So let's write 2 times 2. We need a 2 times 3. We already have a 2 right here, so I'm just going to write times 3, because like I said, it's the minimal string that happens to have everything. And then we need a 3 times 5. There's already a 3 in there, so we just need times 5. So 2 times 2 times 3 times 5. It does technically have all of those factors in there. You got the 2 times 2 right here. You got the 2 times 3 right here. And then you got the 3 times 5 right here. And this is equal to 60. So that is your least common denominator in this case. So it's not a method that people seem to use very often, because usually there's easier methods, but it is foolproof, and yeah, it'll always work. But yeah, still, I think my method's better, because like, just look at 15. 15 doesn't work. It's not a multiple of either of 6 or 4. And then you go to 30. That doesn't work because that's not a multiple of 4. Then you go to 45. That doesn't work because it's not a multiple of 6 or 4. Then you go to 60, and bam, 60 works for all of them. So you'll get the same answer regardless, but usually doing it this way will at least save you time. Although doing it that way, you do have to do some mental arithmetic. Does anyone have any questions? Let's see what else there is. Let's Let's do one more because we haven't really done an example where we added up 3 fractions. So we'll do one more and then we'll do some subtraction, which is virtually the exact same thing. The only difference is that you subtract them rather than adding them. So this one's also in the PowerPoint. It is 1/2 plus 1/5 plus 3/7. Okay. Oh, this one's really neat. I just realized something super cool about this one. Yeah, I just noticed that all the numbers on the bottom are prime numbers. 2 is prime, 5 is prime, and 7 is prime. So by deduction, you know that the least common denominator is just going to be the product of all 3 of those numbers. Because if you used your prime factorization method, they're already prime factors. They're prime themselves. So it's like 2 would be broken down into 2. 5 would be broken down into 5. 7 would be broken down into 7. And it would just be the least string of numbers that contains 2 and 5 and 7, which is just 2 times 5 times 7. So that's kind of neat that in this case, you could just, some people could just kind of automatically deduce that all you got to do is multiply the numbers together in this case. So 2 times 5 times 7 is 70. 70, very good. Okay, now let's rewrite these. For 1/2, that's pretty easy to rewrite because like 35 is half of 70. So you're going to end up getting 35/70 for that part. But let's keep it kind of formal. And yeah, let's take 1/2. On the bottom, you would have to multiply it by 35. And on the top as well to get to 70. So that's 35/70. Next one, 1/5. So 5 times what number equals 70? I think it's 14, right? Yes, that sounds right. So times 14, and you get 14/70. And last one, 3/7. So of course, 7 times 10 will get us to 70. So let's multiply this by 10. So 30/70. And now finally add them all up. So 35/70 plus 14/70 plus 30/70 equals something over 70. 35 plus 14 plus 30. That is 79/70. Yep, so 79/70 doesn't look like it reduces. Because 79, I'm not sure, but it seems like it's a prime number. So it looks like it wouldn't reduce. And some people like to write their answer as mixed numbers, and that's fine as well. If you want it mixed or as a regular fraction, just as long as your answer is fully reduced. Okay, so let's go to subtraction, and then we'll be done for the day. Okay, and it's kind of funny. It also lists the general procedure for subtracting fractions, and it's just kind of funny that it's word for word the same as the other previous one, but at the end it just says subtract them instead of adding them. So it's like there's barely even a point in writing that down because it's so similar. But let's look at an example. So 3/4 minus 2/3. Okay, so same thing, we got to figure out our least common denominator. In this case, it's 12. Yeah, and again, you could just do a lot of these by just by observation. Sorry. So least common denominator is 12. So let's take these and rewrite them. So let's multiply this one by 3. So that's 9/12. Let's multiply the next one. So to get 12 on the bottom, multiply by 4, and you get 8/12. And now you subtract them. So 9/12 minus 8/12. And that gives you 1/12. So like I said, virtually the same thing as adding them, except you just subtract the top numbers. So yeah, not much else to say about that. Darn, there was one more thing I was going to say, and then I totally forgot. Oh yeah, I was going to, this is just like a curiosity, but yeah, for some reason I noticed that people have an easier time subtracting fractions rather than adding them. It's like a weird curiosity I've noticed as a professor, because I've seen a ton of tests where a person can't figure out the addition questions, but they can do the subtraction questions. And it's happened independently so many times that it's obviously not a result of cheating or anything like that. It's just a weird little thing that some people can figure out the subtraction ones and they just can't figure out the addition ones. I'm not sure exactly why. So there's a ton of other examples. Let's see. Oh, there's one last thing, and it is comparing fractions. So let's squeeze that in as well. So sometimes it might be useful to compare fractions, especially when you're doing like measurements and technical stuff. So let's look at 1/4, 2/5, and 3/8. And let's say for whatever reason, we want to order these from, smallest to largest or largest to smallest, and, figure out, which is the biggest and smallest and which one's in the middle. But if you just look at them like this, it's tough to deduce that. Like, even for me, it's tough. Like some of these you could kind of, let's see, what would you be able to say about, I guess 2/5 is larger than 1/4, right? Yeah, but it's tough because all the bottom numbers are different. So yeah, they're pretty hard to compare. So the way to compare them is just rewrite them so that they have the same bottom number, and then you can directly compare them just by looking at their top numbers. So similar to adding fractions, except at the end you just look at them and compare them. So let's figure out the least common denominator for this one. So 4 and 5 and 8. Let's use prime factorization for this one, just for fun. 4 is 2 times 2. 5 is 5. 8 is 2 times 2 times 2. So you need a 2 times 2 times 2. So that covers that one. That also covers this one because, yeah. And then you need a 5. So that is guaranteed to be your least common denominator. So 2 times 2 times 2 is 8 times 5 is 40. So least common denominator in this case is 40. This one just seemed like an easy one to use prime factorization with, because like 4 and 8 have the same prime factors. 5 is already prime, so it seemed like a convenient one. Now let's rewrite each of these. 1/4, we want 40 on the bottom, so let's multiply by 10. So we get 10/40, comma, next one, 2/5. So 5 times what number will get us to 40? I guess that's just 5 times 8. So times 8 times 8. So that's 16/40. Another comma, and then you got 3/8. So 8 times what number gets us 40? That would be 5. So times 5 times 5, and you get 15/40. So now these are a lot easier to compare. You got 10/40, 16/40, and 15/40. So of course, 10/40 is the smallest one. And this symbol I'm writing is the less than symbol. So it's just a convenient way to order them. Next one would be 15/40. And that is less than the last one, which is 16/40. So there you go. In this case, I would kind of rewrite it in terms of its original fractions. So let's do that, because yeah, 10/40 was 1/4. And that's less than, so 15/40 is 3/8. And that's less than, and then the last one was 16, that was 2/5. So good, 1/4 is less than 3/8, and that's less than 2/5. Good. So that's how you compare fractions. And let's see. Oh, and then one super last thing, just a common table of symbols. Let me go to my PDF. So here are some common math symbols that you might see me using. Because one time I was using them and I forgot that people don't know these symbols. So yeah. So hopefully everyone recognizes the first symbol. That's an equals sign. Pretty self-explanatory. The next one is a greater than sign. After that is a less than sign. And then the two after that are pretty much the same, except for this one, it's less than or equal to. And this one is more than or equal to. So by having that extra line underneath the symbol, it includes both equality and then the less than or greater than part as well. And this is going to sound silly, but I remember in grade school, the trick they had us for remembering these was that it's like a mouth and it wants to eat the larger number. And that's how you remember which one is the less than symbol and which one is the greater than symbol. And that's still how I remember it, to be honest. Stuff like that sounds silly, but that's kind of, the human brain isn't really good at memorizing arbitrary information. Yeah, like they even have these giant competitions where people will just try to memorize stuff. Like they'll look at a deck of cards for a minute and they'll try to memorize that. And even the people who are champions at that, they don't actually memorize it. They'll use tricks. Like they'll look at the cards and they'll come up with a story where each story element is a card. And then they'll tell the story to themselves and they'll be able to remember the entire order of the deck of cards. So stuff like that is always the easiest way to remember things. Okay, so 5, okay, that was a solid lesson. No point in moving on to anything else. Let me just update the attendance. And if anyone has any questions in the meantime, let me know. So that person, and I think I got, okay, I got that person. So many people. What else? Yeah, I think I got everyone. Okay, and there's another person. Okay, noted. So that person's here as well. Good. Okay, so like I said, tomorrow I'm just going to do it on Zoom from my apartment. So yeah, if you're going to be stuck at the school all day tomorrow, bring your laptop, make sure you're prepared. And then another reminder, first assignment is due next Wednesday, and we'll take it up on Thursday. And then tomorrow we'll start on chapter 2. And then, yep, I got you as well. No worries. Okay, so I guess that's everything. I will virtually see everyone tomorrow, and have a great day. Bye.
Bye.